Welcome to Bite-Sized Data Science. It's time to get back to some technical examples. I often work with open source data coming from different sources. I've talked about some of the sources in videos 19 and 20 about the Socrata catalogs and datasets. When I read this data, I end up with CSV files and some information on what the fields represent. What if I want to write the data to a relational database? I have to create a table definition that fits the data. This can be time-consuming, especially when there are many columns. Let's see how I can make this less painful. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I am using here are also available in the description. I happen to have access to an instance of IBM DB2 on cloud. This is the database I'm using in this notebook. What I'm demonstrating here should be easily adaptable to the database of your choice. I am using the Chicago accident data I use in videos 17, 18, and 32. I first read the data in a pandas data frame. As we saw in video 18, I need to convert the date-time columns to the proper type. The result is the following list of columns with these specified data types. To make it more generic, I create a dictionary that provides mapping between the data frame column type and the equivalent data type for DB2. The main issue with generating a table definition from the data frame data is to figure out the maximum length of character columns. The following cell uses the NumPy vectorize function. I first create a data frame that contains the column names and their data types. I then add a column for the maximum value length. To reduce the processing, I use the pandas method select_dtypes to limit the columns to process to the string ones. The result is a pandas data frame that contains all the information I need to create a table definition. The next cell prints out a basic table definition based on a column info PD data frame. The reason I print out the table definition is that I can then review it and make some corrections before I create the table. The main processing of this create table cell is to look for object types and convert them into either char or varchar types with the appropriate length. Once the execution completes, I can copy the table definition and use it. We could leave the Watson Studio environment and use other methods to create the table and load the data, but let's continue the processing in our notebook. Because of some previous data exploration, I made simple changes to the table definition. First, I explicitly named the schema to use in the database, and I identified the first column as my primary key. There is more I could do. For example, some values defined as bigint could be integers instead. Also, some double values could actually also be integers. The reason for the choice of data type is because the original pandas data frame used those types for the columns. I made one more change. The last column, location, was a varchar 40. Instead, I decided to take advantage of the DB2 spatial extender to convert it to a point data type. This way, I could decide later to create an index on the location and take advantage of database spatial operations. Now we can create a table. We could use other utilities to load the data, but let's see how we could do it in our notebook. Since it is just an example, I'm only using the first 10 rows of the original data frame. I could write the insert statement myself, but instead I'm taking advantage of the information I have to generate it instead. In this example, I have 48 columns. It could be really easy to make a mistake on the number of parameters, so I use the same approach as a create table. I use Python to generate the insert statement and print it out. I need one question mark for each column in the table. In case you don't know, I use a Python capability of multiplying a string by a number to get multiple copies of it. In this case, I multiply the string question mark comma by 47 and then add the last question mark. I can then modify the insert statement before using it. Remember, I changed the last column, location, to a spatial point. What I am inserting is a character version of it. To accommodate this, I use the spatial extender function st_point from text to do the conversion. I added the geographical reference system represented by the number 4269. Spatial data processing is complex. If you want to know more about it, please review videos 44 to 50. Inserting the records is simply looping over the pandas data frame and executing the insert. You can see, after the execution of the select statement, that records were inserted. There are probably better ways to do it, but this one works. Creating table definitions to move CSV files into a database can be time-consuming. The code presented here should save you some time in doing this work. See you next time on Bite-Sized Data Science, and don't forget to subscribe.